Good morning children. Welcome to your chemistry online class. Much properties of periodic table. We know periodic table having 18 groups. It having 18 groups and it is having 18 group and 7 periods. 18 group and 7 periods in the periodic table. And we discussed a lot of properties. And if we check each group and each period, they are showing some similar properties or some trends. So in today's class we are going to discuss about the trends along the periodic table. Before going to that, you have to know how to write the electronic configuration. I hope all of you know how to write the electronic configuration. For example, we know the shells, the electrons are arranged in the shells of the periodic table. We know it's contain 4 shells: K shell, L shell, M shell and N shell. So it is arranged in the electronic configuration is the arrangement of electrons. So the number of electrons which can accommodate in each shell given by the formula 2n square. We know the n of K shell it is 1, the L shell it is 2, M shell is 3, N shell is 4. So instead of this n for K shell we can put 1. So 2 into 1 square, that is 2. So the maximum number of electrons which can accommodate in the K shell it is 2. L shell it is 2 into 2 square. 2 square is 4 into 2, 8. M shell similarly 18, but it will accommodate only 8 electrons in order to decrease the repulsion between the electrons. N shell also 8. Similarly it will goes on. So if you check the periodic table, we can see the electronic configuration. So there are some patterns of electrons arrangement in the periodic table. So let's check with the first 20 elements in the periodic table. And what is the pattern of outer shell electrons in a group? And if we check the group, we can see that the electrons in here we can see that in the periodic table we can see the elements are arranged in the arrangements of electrons are known as so if we check the electronic configuration, we can see that along the period, what is the pattern of outer shell electrons in a group? This outer shell electron is known as valence electron. If we check along the period, we can see that the number of valence shell electrons, that is number of outer shell, 1, 2, 3, 4. Similarly, if we check the number of valence electron increasing along the period. Here you can see that if you take the elements, the second period element which are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. If we check the atomic number increases along the period. And if we check the electronic configuration, the number of valence electron, here you can see 1, 2, 3, 4, 5, 6, 7, 8. So the number of valence electrons increases, but number of the shells remains same, but the number of valence electron increases across the period. So the property of valence electron, number of valence electron increases along the period. And if we check in a group, if we check the number of valence electron, it remains the same. In a group, number of valence electrons are same. So number of shells increases even though, so it is in K shell, it is in K L shell, it is K L M shell, like that it will increases even though the number of valence electrons remains same in a group. So in a group, in a period, the number of valence electron increases, but in a group the number of valence electrons remains the same. And We'll move to the valency. What do you mean by valency? Valency is the combining capacity, or it is number of electrons accepted to fulfill octet. What do you mean by octet? It is number of electrons, that is 8 electrons in the valence shell. And if you take this, you can see that here we'll check with the second period element. If we check the second period element, similar, the atomic number along the period. We already discussed about the valence electron. Valence electrons are increasing along the period. So we know the valency is the number of electrons required for an atom to complete its octet. And it can define it is number of electrons accepted or number of electrons donated. Here if you check, the valency increases to 4 then decreases. So we can say that the valency increases along the period and reach a maximum then decreases. For example, if you check with oxygen 6, it's atom number 6, so its configuration is 2,4. So in order to attain stability, that is 8, it needs 4 more electrons, so its valency is 4. If you check with nitrogen, it has 5 electrons, so 3 electrons more need to complete its octet. So the valency is the same. And so we can say about the valency, in a period the valency of elements increases from 1 to 4 and then decreases from 4 to 0 in the left to the right in a period. If we check in the group, the valency remains same. So the valency is same in a group. Then atomic size. What do you mean by the atomic size? Atomic size means the size of an atom. How can we determine the size of an atom? We can define the size of an atom is, it is the distance from the nucleus to the, we know the nucleus is in the center of an atom. It is the distance between the center to the outermost shell of an atom. So if we check the periodic table and if we check the elements in the second period or in any period, we can see that along the period number of valence electrons are increasing, but the number of shells is not increasing. The all electrons in the K and L shell. If you check here, you can see that all electrons on K and L shell. For each element, it is in K and L shell. So the number of shells is not increasing, but the number of electrons increasing. Similar to that, number of protons also increasing. So the nuclear charge, it is the charge of the nucleus. We know protons are situated in the nucleus. So the nucleus having some charge. So it will attract the electrons in the each shell. It has the ability to attract the shells in the each shells in the electron. So according to this, the nuclear charge increases along the period. So the size of an atom will decreases because it will move towards the nucleus, because so the size of an atom will decreases along the period. And if we check with the group, the number of shells increases. For example, for lithium there is only one shell, but in the case of sodium it has 2 shells. If we move to potassium, it has 3 shells. So number of shells increases. As number of shells increases, what will happen? The distance from the nucleus to the valence shell also increases. So the size of an atom will increases down the group. Here you can see that down the group, the size of an atom increases as number of shells increases, and along the period, the size of an atom will decreases. These are the trends in atomic size. Then if you move to the metallic property, we know in the periodic table, left side which have metals, if we move from left to right, the metallic property will decreases. For example, if we check the third period elements, sodium, magnesium, aluminum, silicon, phosphorus and sulfur, chlorine, argon, I request all of you take your you have to take this class with your periodic table. So if you check here, you can see the third period elements, and the third period element, if you check, sodium and magnesium and aluminum, those are metals. Silicon is metalloid. Metalloid are the compound or substance which show both the properties of metals and non-metals. And if you check here, phosphorus, sulfur, chlorine, argon, those are non-metals. So we can say that the metallic property decreases along a period. And if you check along the group, if we are taking sixth group, that is carbon family. So in carbon family, we can see that carbon is a non-metal, silicon and germanium are metalloids, and tin and lead are metal. So the metallic property increases. Metallic property increases down the group. Then what about the non-metallic property? Just opposite to the metallic property. So we can say that in a period, the non-metallic property increases, and along the down the group, the non-metallic property decreases. So this about this chapter. So thank you. I hope all of you understood today's topic, and we'll discuss more about this in next class. Okay, thank you.